Here is what the prompt says. It says, generate a square with 4 quadrants, each of different color, then illustrate a forward diffusion process viewing the square as an image in HTML5, which gets progressively noisier. So here we're going to take a look at what this noisy concept looks like in a forward diffusion process using these squares, apparently. So let's just take a look at what that looks like. And again, you're going to get a look at the illustration of the diffusion effect, and here we have our diffusion squares, and you can see they're getting noisier and noisier as this forward diffusion process takes place. So as my limited understanding goes, I believe then this would need to be reversed to generate an image or a video based on this original input. So it's kind of the inverse of this forward diffusion process. What is up, everybody? Welcome to another episode of the AI Marketing Navigator. This is your daily compass in the ever-evolving world of AI marketing. Okay, navigators, we are back today talking about a brand new type of AI model, specifically a new type of LLM that is called a dLLM, a Diffusion Large Language Model. And this is news coming out of Inception about their new dLLM model called Mercury, which is being pitched as the first commercial-grade diffusion large language model. So today we're going to dive in, do an explainer on what a dLLM is, how it differs from traditional LLMs, and how it performs compared to traditional LLMs. So let's go ahead and get started. First, a little bit of background on the company Inception. It was founded by Stefano Erman, a professor at Stanford, and also co-founded by Aditya Grover and Vladimir Kuleshov, a UCLA professor and a Cornell professor, respectively. The company emerged from stealth mode in early 2025, so just earlier this year. It should come as no surprise that it is located in the heart of Silicon Valley in Palo Alto, California. Their mission is to revolutionize AI by combining the generative capabilities of large language models with the speed and efficiency of diffusion models. Okay, so now let's do a little bit of an explainer on what a diffusion model is. It is a type of AI model that has traditionally been used to generate images or audio or video, but the team that created Mercury wanted to see if it could be applied to text, and they do this through something called the coarse-to-fine approach. Essentially, the model is going to iterate through the initial input, the noisy input as it's called, and go through a series of steps to denoise that input until a coherent output is reached. And the primary way that this differs from traditional LLMs in the way that they structure outputs is that it allows for a parallel processing, so processing multiple things at the same time. So in the context of language and text, diffusion models like Mercury, in this instance, basically start with a rough estimate of what the output should be, the text, and then through the course of those parallel refining steps or denoising steps, they refine that output. In a traditional LLM, they process what's called autoregressively, which is where they generate text sequentially, one token at a time. And we've talked about this method before. And then each token essentially depends on the previous ones, which can lead to more latency and slower processing times, especially compared to the parallel processing. And the primary results of this are increases in speed and efficiency, mostly due to that very key parallel processing feature. For instance, Mercury achieves speeds of over 1,000 tokens per second, whereas traditional models typically are sitting at speeds of 200 tokens per second. So there's a very significant increase there. And this allows for much more efficient use of GPUs, which lowers the cost of inference, which is great news for AI accessibility and democratization. One of the areas that Mercury's dLLM approach shines in particular is in coding. And one of Mercury's first releases is the Mercury Coder, which we're going to demo here in a bit. And it compares to models like GPT-4o Mini and Claude 3.5 Haiku, except that it can be up to 10 times faster. So it's achieving performance that typically would have taken very specialized equipment beyond a typical GPU, an H100 or an NVIDIA GPU. But that is no longer the case with this diffusion large language model, which has led many people in the industry to believe that dLLMs are a promising alternative to traditional autoregressive. And the early performance of Mercury suggests that perhaps diffusion large language models can apply just as well to text as they do to audio and video and images. However, there are still some challenges and limitations that are unique to dLLMs, particularly in scaling and training. So what they're able to achieve in speed and performance and efficiency, they actually lack in training efficiency. They're harder to train, So definitely a bit of a trade-off there, but still a huge step for AI and all of us who use AI as a tool in our tool belt, as diffusion models have now for the first time been applied to text generators or text generation. Now, regarding pricing, it appears that the Mercury coder is actually free to try out in their quote-unquote playground. And right now you're actually looking at the Inception home screen. Right up here in the upper right-hand corner is where you can click to visit the playground. And this is going to give you access to the Mercury coder. And you don't have to sign in or create an account or anything. Although it says to get full features, you do need to do so. So there are some features that you will have to sign in to get access to, apparently. So we're actually going to test out one of the example prompts that they give us. Most of them are coding related. And the one that I ended up using for our demonstration, you're not seeing it right now, but it was write a form of Minesweeper in HTML5 and CSS and JavaScript. So we're going to do that really quickly here so you can get a look at the Mercury coder in action. And actually, I'm just super curious in what this bottom one is here. Illustrate a forward diffusion process in HTML5 that I'm going to call a little bit of an audible here. And before we hop into the demo of our Minesweeper game, let's just go ahead and prompt it to generate this illustration of a diffusion process. Here is what the prompt says. It says generate a square with 4 quadrants, each of different color, then illustrate a forward diffusion process viewing the square as an image in HTML5, which gets progressively noisier. So here we're going to take a look at what this noisy concept looks like in a forward diffusion process using these squares, apparently. So let's just take a look at what that looks like. And again, you're going to get a look at the illustration of the diffusion effect. And here we have our diffusion squares, and you can see they're getting noisier and noisier as this forward diffusion process takes place. So as my limited understanding goes, I believe then this would need to be reversed to generate an image or a video based on this original input. So it's kind of the inverse of this forward diffusion process. Okay, now let's get into our regular demo where we're going to build a Minesweeper game. We're going to let Mercury Coder build a Minesweeper game for us. Okay, so let's fire up the Mercury coder here and give it a test drive. We're just going to write Minesweeper, which is one of their little default prompts here. It says in HTML5, CSS, and JavaScript, write Minesweeper. And for anybody who's not watching along on video, pretty standard looking interface as far as a LLM goes. It does say here, try our first commercial grade diffusion LLM. And again, we have this little diffusion effect up in the right-hand corner that we're going to try out. It says that it shows an animation representing the text diffusion process. So let's go ahead and fire this up and see how long it takes to write Minesweeper. We'll let it run in real time. Again, looks like we can see here's our animation showing the diffusion process, and it's done. So it took all of maybe 5 seconds, if not less than that. So you guys all saw it there in real time. We have our game here on the right-hand side. So it looks like we do have a artifact or a preview happening here in Mercury as well. Let's see how the game plays. Pretty standard, and it looks like you can flag with the right click. So I am pretty impressed. Again, this is one of their default prompts, so I would assume that it's ready to crank that out in no time. So maybe let's give it a prompt that's not one of its default prompts and see how it handles that, just to really give it a somewhat decent test, just to push the model a little bit in our somewhat limited testing here. Let's see how it handles like writing a Space Invaders type game or like an arcade like shooting type game. So let's say, please write a Space Invaders style arcade shooter. So let's see how it does with this. Again, watching it in real time here, we're seeing an animation with our diffusion, and it really takes about as long as that. And it actually tried to get a little fancy on us and write some Python form of the game and having us install Pygame packages and stuff like that. So let's go back and try a new prompt. And this time we will specify that we wanted an HTML5, CSS, and JavaScript as well. And we can see there's another couple suggested ones here. Create a Pong game, make a tool in HTML5, CSS, and JavaScript. But let's just stick with our Space Invaders shooter. Make a Space Invaders style arcade shooting game in HTML5, CSS, and JavaScript. And we'll see how this one goes. And here we have our Space Invaders style game. Not quite figuring out how to shoot, but it does move when we move our arrow keys back and forth. Nothing with the space bar or anything like that, so we might have to specify how to shoot in the game. But again, as far as speed goes and cranking some stuff out really fast, really fast, and performance, I'm really impressed with the dLLM, the Diffusion Large Language Model, and I can't wait to push it a little bit harder with some of these coding prompts, and specifically try and build out some tools that can be handy or useful maybe to use as some lead generators. Anyway, like I said, you should be able to fire this up for free and start testing it. Let me know. You can share these generations and these coding generations, so share what you guys are building. I would be very curious to see. Okay, that does it for today's episode. If you enjoyed the show or found it useful in any way, please do me a favor and follow on Spotify or subscribe on your podcast platform of choice. A review on top of that would be even more appreciated. It is by far the most helpful thing you could do for the show. Also, if you are watching on YouTube, make sure to hit that subscribe button and turn on all notifications so you get notified each day when our episode drops. Until then, and as always, thank you so much for joining me. And remember to stay curious, stay consistent, and keep navigating forward. Bye.